Hi, everyone. Welcome.
We're here for another webinar. I'm Marty, the Science Guy. This is my colleague and co-conspirator, James, and we're here to have fun and help you have fun and learn some things about the way the world works. That's really what science is. It's the study of nature and the way the world works. And I don't want you to think we have it all figured out yet, because we don't.
Nope.
There are lots of things in just about every area of science where scientists just scratch their heads and say, I don't know. And so if you're interested, you can join the quest to find out more about how the physical universe operates. We're doing things in space and electricity and chemistry and all the air biology, marine biology, all these subjects. And there's some things we know, but a lot we don't. So if you're curious about these, you might want to make one of them your job, your vocation. That's another way of saying job. And so I invite you to look at that possibility. Anyway.
Yes. Now, it's okay to not know something.
Right.
And it's even better to know that you don't know it. A good scientist will say, I don't know the answer to that question. Isn't that exciting?
Yes.
Let's go try to figure it out.
Well, there's this old expression that I heard. The more you know, the less you know. Yeah,
yep,
that's right.
That checks out.
Okay.
All right. A couple of questions. Is our background a real picture? Yeah, that's a real picture of lightning striking
in slow motion,
a house or something like
forever.
that.
No, it's a screensaver.
And oh, someone wants to know what your shirt says.
Oh,
there we go. Never trust an atom. They make up everything.
Yes, they do. They make things up all the time. And we're going to be talking a little about atoms, because atoms have to do with electricity. So I got an email recently from my brother, who's older than most of you, who said, I'll be checking out the rest of your videos in hopes that you'll teach me something about electricity. So Gary, this video's for you. Before we're going to find out about elements and motors and electricity, but before we jump into that, let's back up a little bit to atoms, because atoms are what makes this whole thing work. Our knowledge of atoms is what makes electricity. An element is, you can't see an element there. I mean, you can see lots of atoms together, but elements are made of only one kind of atom. For instance, water, H2O, is made of H, hydrogen, 2 hydrogens as a matter of fact, and 1 oxygen. So that's not an element, but the hydrogen is and the oxygen is. And there are over 100 elements. You're probably familiar with some of them. Let's see, there's hydrogen, there's oxygen that makes up water. There's carbon that makes up carbon dioxide. There's iron, there's copper, it's what pennies are made of. So you're familiar already with some of these elements. An atom is the tiniest part of an element that still has the properties or characteristics, or it still acts like that element, but it's very, very, very tiny. Okay, we're going to review the 3 parts of the atoms. If you will bring up our first screen.
Yes.
We will take a look at a good old sodium atom.
Oh, good. Before we talk about sodium, if you want to go over anything in today's webinar again in the future, you can find a recording of this and all the other webinars that we've done at youtube.com/the Delphian School. All 200+ episodes are up there. If you missed where Marty was talking about stuff,
I always talk about stuff.
and you want to hear more about stuff, or me talking about space, or Corey talking about writing, Robin talking about American history, you can find all those webinars on our YouTube page.
Yes, so please view and review and tell your friends. The price is right. Now we're going to take
on to sodium.
On to sodium. Ta 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 ta. Here it is. So it has, let's see, how many red dots? It has 11 red dots. Those red dots represent electrons, even though electrons are really much, much tinier than the protons or the neutrons, which are in the middle. Now the protons are positive and the electrons are negative, and all that means is when you have positive and positive, they push each other away. When you have negative and negative, they push each other away. When you have positive and negative, clunk, just like a magnet. You've probably done that with a magnet. Anyway, the mass number is the number of protons and neutrons that an atom has. So, and the atomic number is the number of protons, and the atomic number will tell you what the element is. If the element has 11 protons, it's good old sodium. If it has 12 protons, it's beryllium, it's something else. Okay, here we go. You've heard of, let's see, some elements.
Next one here.
Oh, nope. Okay.
Don't look at that one yet.
Don't look at that one. It didn't happen. It's not there. Okay. Here I have a battery and a little teeny light bulb.
Let me angle the camera down just a little bit so we can see the table better.
Okay. There we go.
There we go.
And you can see this light bulb lighting up. And it's doing that because there's the element copper in here. And copper is a metal, and metal's conductive. And what that means is it'll let electrons pass through. Now, James, we could look at that next picture.
Okay.
There are some atoms, or there are some elements that will let electrons move through them. And that's what's called a conductor. They have electrons that are not held on tightly, that are held on loosely, so that when another electron comes, like from a battery, the electrons that the metal was holding, it'll let go of that one and grab onto the next one. And that's what a conductor is. And there are some things that won't let go, and they're called insulators. And so insulators, you can try and have electricity go through them. It's not letting go of their electrons, like that guy you see on the right. So now we're going to try a little experiment. Here I have a metal spoon, and if I take it and I touch it there, it lights up because, can you see it?
Yep.
Because
metal
is a conductor.
Yeah, that metal is a conductor.
Now here,
popsicle stick.
Popsicle stick.
What do you guys think? Do you think that's a conductor? Do you think it's going to make the light bulb light up? Let's see.
Nada.
Nope.
Zippo. Now, sometimes
yeah, they were right. A bunch of people said nope.
Nope is correct. Now, sometimes if you're doing an experiment like this, for instance, and you combine it and it should light up, but it doesn't, then it's time to play the game that I call electrical detective, where there's something not working. Right. It could be the light bulb's burned out. It could be the wire's not good. It could be the battery's not good. So what you can do is you could take it like this and take out one of the wires and just attach it, and oh, it lights up. So I know the battery's good, I know the wire's good, and I know the bulb is good. And then I can try, and then you can figure out what's not working. So if this happens to you at home, this is what you can do. You can play electronic detective. Now, get rid of that page.
Okay.
And, so batteries like this have a paste inside. You could see it on that picture. There's a paste, or a kind of a dry, liquidy, putty kind of stuff. And the outside of the battery is zinc, which is a metal, of course, which is conductive. And the inside is this graphite rod. Graphite is what you use for a pencil. When you're writing with a pencil, that's graphite. Anyway, the paste reacts with the zinc and it attracts negatives. And then the positive is attracted, the protons, you could say, is attracted to the inside, the carbon, and that will form more of a positive. And so you have separated positives and negatives. Now remember, the electrons are really, really tiny, and they can flow through a conductor like this wire or this spoon, and they will create a flow. Like a flow of water is the movement of water. Well, a flow of electrons is really what electricity is. So we have that, and now we're going to talk about an electromagnet. Now you guys know what magnets are. They attract metals, right? And they're usually made of iron. In the Earth's core, we have iron and nickel, which are both magnetic metals, which is what gives the Earth its magnetic field, which protects it, and that's another whole webinar.
Yeah.
But what we're going to do, all motors use an electromagnet, and all an electromagnet is some wire, like this wire, wrapped around metal. So in here, in this little container, there's metal. And what that does, what it means is whenever electricity is running through it, this becomes magnetic. Now, of course, for electricity to work, you have to have a circuit. And so, I don't know if you can see it here, but there's this very little itty bitty space right there. And when this is an electromagnet, this part is attached there. And when it does that, it moves away and makes this little tiny space. So it's not a circuit anymore. So this isn't a magnet anymore. And so it goes back. And now, now it's touching again. And so it's attracted. And it does this really, really fast. So I'm going to plug this in. Just going to attach one part there, anywhere, and the other part to right there.
Hey.
And when I do that, you might be able to see right here a little teeny spark. I don't know if you can see that. Next period. Oh, no.
Hello.
So what's happening is this is just doing it it's attracting it. Now it's not a circuit anymore, so it's not electrical, not electromagnet, and it comes back out. Now it's touching, it's a circuit, it's and it just does this really, really fast like that. So this is how doorbells work. Doorbells use electromagnets. And what are some of the things that you can think of that use magnets or electromagnets to work? Glasses don't use magnets or electromagnets.
No, I don't think so.
Not yet.
Not yet.
Maybe someday, but
Yeah.
not yet. So what are some of the things that you know of that can use electromagnet? Well, we know motors. Here's a motor, and you can see this part right here with the wire is the electromagnet. And look, it even has a north and a south. So
Yeah.
these two pieces at the end are
North,
magnets.
south, yeah.
Right? And this is the electromagnet in the middle with the wires wrapped around it. And let's see if this will work.
Okay.
I take this, I put it there.
We had someone say lights.
Lights, of course, lights use electricity. And I'm going to show you in just a minute how electricity is made. And there we go.
Yeah, there we
There's
go.
our little motor that's going around, because what's happening is, I'll just stop it for a second. Let's say this is south and this is north, the permanent magnets, the regular, these square magnets, cube magnets. So when I have electricity is going through here, this part of the electromagnet is south and this part of the electromagnet is north. They don't like that. They want to get away. So they push away, and when they get right about here, this little piece switches them, and it makes this part that was south over here, it makes it north. And this part that was north makes it south. So it gets away again, and then it switches again. And that's why it keeps spinning around. And all motors use electromagnets.
That is so cool.
Yeah. So
Audia says trains. Yes, there's trains
Sure.
that definitely use electromagnets. Evelyn says cars and phones.
Yeah, here's a big speaker. And I have it, a large one, just so you can see it, but this is the same kind of thing that you would have in a cell phone or a telephone or a radio, anything that. So can you see what's happening here? Whenever I touch
Bouncing
it,
back and forth.
it's going in. It's going in. And I'm going to switch it, and I'm going to put this one over here now, and this one over here. And now, maybe you see it better this way.
Yeah, it's bouncing up and down there.
It's coming up whenever I make this circuit. And so this is actually how speakers work. And microphones, if you bring up that next picture.
Yep.
Here is a picture of a microphone. And ooh, what's that in the middle? That's a magnetic coil. It has wires wrapped around it. That's an electromagnet. And what microphones do is they take the vibration of the air and change it into an electrical signal. And that electrical signal, for a phone, for instance, can get sent somewhere else. And then the other end of your phone has a speaker in it. And the speaker changes the electrical signal into sound. And so that's how all telephones,
That's so cool.
all microphones, all amplifier just means to make large.
Mm-hmm.
So amplifiers will take that little bit of a sound and make it loud so you can hear the music well, even in the back of the room.
Yes.
So microphones and speakers use this electromagnet.
Yeah.
There weren't any electromagnets, we wouldn't have any of that stuff.
Well, that would be a bummer. Ethan's asking, is this class more advanced on the Heron Books check sheet, electricity in the home?
This
question.
is sort of a combination of electricity in the home, simple electromagnetic devices, and just fun stuff that I picked out because it has to do with electricity.
Yes.
Now,
someone was asking earlier, and I saw your comment. I didn't have a chance to answer it yet. Yes, the discount code for Heron Books that we've been showing at the end of each class, that is still available. It'll be available at least through the end of this week. I don't know exactly how much longer after that, but if you're interested in getting any of these courses from Heron Books, do so in the next week. And then on Friday during our grand finale show, which I really hope that you all tune into, we should have some news on how long that code will be available and what's coming next. Yeah.
thank you. Okay, so James and I know what this is because we're old, but you probably don't. Games, remember your Commodore 64?
Yep.
Would have games. That's an old computer, very, very weak. But anyway, it would play games. And it had information here on this, which
Floppy disk
is called a floppy disk. I wonder why they call it a floppy disk.
Well, it comes in this, and I used to wonder why they called this a floppy disk, because it's not very floppy. And then I broke one and saw that inside there was a bit that was floppy.
And this works because this has electromagnetic data, which your old computer which our old computer could read, and we would have a game, and we would be able to play a game on it, whether it's Space Invaders or whatever, Pac-Man. It would be on that information, and all of the whatever the computer needed for that game would be on this floppy disk.
Mm-hmm.
And it's
Number
all
Crunchers. That was a game I used to play all the time in school. Was Number Crunchers, this really cool math game, and Oregon Trail.
All right.
Yeah.
Anyway, this is old technology, but if you have your mom has or dad will have a credit card, there's a magnetic strip on the back And that's also electromagnetic, and it's carrying information as far as who the card holder is and all of that info, what bank it comes out of, all of that information is held electromagnetically on that little tiny strip in the back. As a matter of fact, we're going to look next at a hard drive. A hard drive is what holds the information on your computer. And there's one with 1, 2, 3, 4 different hard drives, it looks like.
1, 2, 3, 4. Now, just in defense of us, yes, this is now considered old technology, but I promise you, it was cutting edge. This was brand new. This was the new iPhone. This was the new computer. This allowed us to do so much more with computers than we were able to before.
Right.
And then we moved on.
Right. Advancements made things better, faster, easier. But this, when you bought a computer, it would have a little slot for floppy disks back in the old days. This was right after the hammer and chisel on the stone wall.
This is shortly after we discovered fire. Yeah.
So, so I'm just letting you know this because I want you to know that what we have now is not going to be the latest thing. Technology is changing so fast that, you know, a computer that you had 2 years ago could be an old computer. I have a computer at home from just a few years ago, and I had to get rid of it because it was too slow.
Yeah.
And I thought, I have 2 gigs of hard drive. I'll never use 2 gigs. It got used up in a flash because people find more and more things to use it for, applications.
I have a game on my phone that's more than 2 gigs worth of data by itself.
So things change. So this hard drive stores information electromagnetically. Now, there are some things that look like that don't store them electromagnetically, like a CD and a DVD. That's not electromagnetic. Those are little pits, little dips in the DVD and in the CD. But these hard drives, which all computers have and all computers rely on today to store information. Who knows, in 5 years, it could be, oh, you have a hard drive? Oh, forget that.
You're old.
You're old.
What's that, a floppy disk? Ha.
Yeah, you know, we have this gizmo, and now this is the 200 gigabytes or 200, you know, whatever it is. Anyway, that's for the future. But right now, all computers have this hard drive that stores information. Okay, we're going to take a look at our next thing. Have you ever gone shopping? That's not it. We'll talk about this though. This is
okay, good.
This is a security device. People have it installed in their home, on their doors or on their windows, and those 2 pieces are magnetic. So you could have the window either closed like it is now or open a little bit. But for doors, it's always when it's closed. And when that electricity, those 2 magnets are not touching each other, it sets off an alarm. Sometimes you have a little delay, so you could open up the door, punch in a code, and then the alarm won't ring. But this is technology that uses electricity and magnets. It uses electromagnets.
It's very simple, but it's a really smart use of it.
Right.
Yeah.
Let's take a look at our next picture.
Okay.
Oh, those are cool looking shoes. You know, I always wanted to get I've seen kids going around in these shoes that light up, and I wonder why they don't make it for grown-ups. I would love to have a pair of shoes.
We should do that.
We should start our own company. Anyway, what's that little tab, that little white thing that's on there, the big white thing? It looks like it's about yay big. That's on that pair of shoes. You guys have seen this, you know this. They come in all different shapes and sizes. I've seen them where they're round. I've seen them in when they're a little wider. Anyway, this is something that's what? Let's see.
ISIS says makes it so you can't steal it. That's
right. You can't steal it. That's right. That's a magnetic device in there. And if you'll notice by the stores, When you go out, there are these things. They will detect if there's something that's magnetic that's going through there. So again, this safety technology uses electromagnets. This is a great technology. You don't have to have a guard there at the door saying, you have a receipt for that? You know, they have these things. If it's expensive, then people in the stores, the retailers, that's what people are called who own stores, will have those devices on these expensive items like $100 shoes. And so you can't walk out with them without setting off that alarm.
That's right. Now I notice this guy here appears to have a receipt for those shoes, so he's okay.
He's okay.
Yeah.
Okay, now we're going to talk about this next.
That's a cord.
That is a cord, and that's a part that plugs into the wall, and that's a part that plugs into your computer or adding machine or whatever it is.
Thing that needs juice. Thing that needs power.
Electrical power.
Yeah.
And so what happens is that is a transformer. Now,
I love transformers.
I'm not talking about Optimus Prime or Bumblebee.
Oh.
I'm talking about something that transforms or changes the electricity. Now, if you have, there's 110 volts, between 110 and 120 volts coming from a wall plug or a wall outlet. And if you put 120 volts through something like this, you would just burn and fry the electronics.
It's too much power.
Too much. It has to be
like
changed.
trying to drink from a fire hose.
Exactly. Yes. Have you ever tried that?
No, don't try that. Don't try that. I don't even have to try it to know that it's a bad idea.
Bad idea.
Because I can use my powers of observation and my mental reasoning to figure out, without having to do it, it's probably not a good idea.
Not a good idea.
Yes.
We could do a science. No, never mind. So it's a bad idea. It's a bad idea to plug 120 volts right into this. And so you need something that will lower the voltage. And that's what transform means. It transforms the voltage from 110 to 120 to something like 6 or 8 or something like that, that will charge your computer without frying it.
So it's like the nozzle on the fire hose that you can open up just a little bit. I just need a trickle of water. I don't need the whole thing.
Right. Now we're going to talk a little about different types of electricity. Now, this type that you see in the batteries and solar panels give you what's called direct current. And what direct current means is the electricity is flowing from the middle part of the battery, which is where the negatives are, through the wires, through the little light bulb or motor or whatever it is it's powering, and back to the other side, like that, back to the positive side. And when too many of the electrons from the middle wind up on the end, your battery gets weaker and weaker and weaker until it barely lights up the light, and then it stops lighting up the light. And then you have to get rid of the battery and get a new one. And there are some batteries that are rechargeable. Great, you could recharge it. But the electricity that you have in the wall is different. I happen to have a model here.
Ah, how handy.
So this is a model of alternating current, and alternating means changing. And so you can have current that goes this way, and then it goes that way. So the electrons will move in one direction and then the other. So if you watch this, I don't know if you can see that. Can you see that needle there?
I hope that's coming through well. Yeah, there we go. I'll hold that for you.
Okay.
There we go.
Can you see? Hello. Let's see. Da, 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 da. Da, 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 da. Anyway, what's happening is this needle is going backwards.
Oh, I was holding it too much of an angle. There we go. There's that needle going back.
Yeah, you can see that now.
There we go.
So that's alternating or changing current. And in your wall, the current is going this way and then it's going that way, and it's changing 60 times a second.
That's a lot.
Well, at the power station, these things are spinning around really fast and making this needle go back and forth 60 times a second. And for those of you that are interested, that's called 60 hertz. Hertz means 1 cycle a second. And it's not spelled like, oh, my arm hurts. It's H-E-R-T-Z, named after a man who was an electricity scientist. Anyway, that's what we have in the wall. But you know,
we had a question. Now, I understand that some of you couldn't see that needle going back and forth. I'm sorry that wasn't coming through well, but as we were turning it, as I turned it one way, it went this, and then I kept spinning it, and it went, and the needle went that way.
And that way, and that way, and that way. And it went pretty quickly if you were spinning it.
Depends on how quickly we were spinning it.
Right.
Yeah, and Milo asked, what about a light that you can change the brightness of?
Ah, okay. So what happens there is, I don't know if you remember when we had our talk about resistors. So resistors are something that slows down the current. So for instance, if I had 2 light bulbs, then they wouldn't be as bright because these are resistors. It slows down the current. If you ever attach the 2 parts of the battery, one to the other, the battery will get hot and the wires will get hot because these things, there's nothing to slow it down. They're going really, really fast. And that's a good way to burn out your battery or burn out your wires. But this slows them down. So something that dims the light is called a variable, which means changeable resistor. So you can add a lot more resistance that slows it down so the lights are barely on, or you can have little resistance so they're going really fast so the lights are bright. That's what does that. That's what makes a dimmer switch work. It's called a variable resistor. Okay.
I'm so glad that people over the last thousands of years figured all this out.
Well, it's not only the thousands of years, it's maybe a little over 100 years, because if we could take a look at our next slide, back in the day, there was this big debate. The guy on the left is Nikola Tesla. He's the guy that Elon Musk named his car after.
Mm-hmm.
And because I guess he admired him. So he was an electronic genius. And for a while, he worked with the guy on the right, who was Thomas Edison. But then they got into a dispute, and they went their separate ways. And actually,
they didn't get along very well.
They didn't get along. Do you know they both won the Pulitzer Prize for science for advancements they made in electricity? And they refused, I think it was Tesla, refused to accept his because it was with Edison.
Yeah.
Anyway.
They did not get along very well. Being able to work with others is a very important skill.
Right.
Yeah.
And anyway, what happened is this paper is 1893. There was a World's Fair in 1893. I think it was in Chicago.
Sounds about right.
It was in Chicago until someone proves us wrong. And
maybe
then
Buffalo. It was in the United States.
It was in the United States.
I'll say that with certainty.
Okay. And so Nikola Tesla was someone who was saying, this is the way to make electricity.
Alternating current.
Alternating current. That's the way to do it. Let's see. Is that?
Here, let me come off screen share there.
I don't know if you can see that.
There we go. It's a little bit closer.
There you go. You see
I really hope that comes through. I know it's just a needle going back and forth. It's a little needle going back and forth. It's really interesting.
Anyway, Tesla was the guy who said alternating current. This is the way to go. And Edison is saying, oh no, the way to do it is direct current. Now he didn't use batteries. He used something like this that would spin around and make electric current. The thing about this motor, when I have electricity going in to this, it spins around and it's a motor. If I could somehow spin this around by myself, it would become a generator. Mm-hmm. It would make
it works both ways.
Electricity, right?
Yeah,
right. Electricity going in, it's a motor. Spinning, electricity goes out. So Edison was the one who said, no, DC, direct current, where it goes just, if I had that needle, the needle would just go one way on that AC generator. It would just go one way and stay there. Or it would go the other way and just stay in one direction, not go back and forth. This would be AC, this would be DC. The current, the electrons were just flowing one way. And there was this great debate, and these two people didn't like each other. So it was a great, people didn't know. It's like VHS or versus beta.
Or Blu-ray versus DVD.
Right.
Like, they're both workable. They both work. Which one will come out on top?
And so people didn't know. Well, what happened is AC won out. And the reason AC won, alternating current won, is because alternating current can be sent very, very, very far away without losing much of its energy. For DC current, which is what Edison wanted, you'd need a generator in every small town or neighborhood to make the electricity, because when that was sent far away, it would lose a lot of power.
So you would need a power plant in every little neighborhood. Our power plant would have to be right down the street.
Sure. So that's why we have AC. That's why these two guys had this big fight.
Yep. Now, I argue that both of them won because, yes, the electricity that comes out of our wall comes as alternating current, but but we also use direct current all the time in many things. You're showing us that battery. That's direct current.
That's direct current. As a matter of fact, there are some devices, like my little light bulb, that don't care if you use AC or DC. It'll light up no matter what. But there are other devices that say, I only need DC, thank you very much. I will not work with AC. And so scientists came up with this device called a diode. A diode is a device that changes alternating current. That's a diode. That's a special kind of diode called a light emitting diode. And there are advantages of these light emitting diodes, other than they change AC into DC. One of the advantages of the LED light emitting diode is that it turns on instantly. Now, I first heard about this and I said, so what? If I turn a light on, so what if it goes on in a quarter of a second or 1/100th of a second? I don't care. But what if you're in a car?
Yeah.
And you're going at 60 miles an hour, hopefully with your parent driving.
Yep.
An adult, someone with a license. And the guy in front, you have two people in front, and one of them has LEDs that turns on instantly. And the other, what has to happen is, here's an old-fashioned light bulb. So what has to happen here is the electricity goes through. There are these wires here. The wires get hot because the electrons are bumping into the atoms in this part of the bulb called the filament, and it gets them hot, and then they light up. So if you're going 60 miles an hour, I'd rather have the car in front of me when he jams on his brakes, to have an LED that gives me a little more warning, because at 60 miles an hour, a fraction of a second can make a big, big difference.
Sure can.
The difference between an accident and that was a close call. So there are advantages for something to happen right away. That's one of the advantages of an LED. It can turn on and off rapidly. The other thing about this, I'm going to plug this in so you can see what this looks like. I'm sure you've seen this before. These are the old, they don't sell these things anymore.
See, you called it an old-fashioned light bulb, and I'm like, I don't know. I just thought they were called light bulbs.
Yeah. Not anymore. They hardly sell them in the stores. There it is. You can see the filament lighting up. I don't know, it's hard to see because there it's all lit up, but I can see just the brightness coming from this filament. Now, if I take this out, ooh, they don't sell these anymore. Do you feel, even though we had that in a little while,
It's hot.
it's
Warm.
hot.
Warm.
It's warm.
Yeah.
If you've ever tried to twist one of them off, maybe it just blew, and you're trying, yow, that's hot.
You've maybe seen people like lick their fingers and then unscrew a hot light bulb. Yeah.
This is an LED light bulb. And once I screw it in, it also gives off light, as you can see. But
I'm waiting for it to get hot.
it's not happening. One of the advantages of LEDs is they use a lot less electricity because they don't get hot. It takes energy to heat things up. And I'm just going to unplug this.
Sure. Yeah. Gunbeer, you called it just a couple of minutes ago. LEDs use much less electricity.
They use about 10% of the electricity compared to a regular light bulb. And they're very durable. If this kind of bulb, if the filament inside breaks, get another one.
And every time you turn on a light bulb, one of these old-fashioned filament light bulbs, every time you turn it on is a chance for that filament to break.
Right.
I've rarely seen a light bulb burn out while it was just, it's on and then it's off.
Right. Usually it's when you
turn on the switch and it turns on for a split second and go and it's gone.
Right. And one of the advantages of the LED is it can turn on and off very, very, very quickly. No problem.
Unlimited numbers of times.
Right.
Yeah.
And so this thing will not only use less electricity, it'll also last much, much longer, maybe 100 times longer than this guy.
Yep.
And
that's not that these things are useless. The longest burning light bulb in history is still burning right now. It's in a fire station in Boston. It is only turned off once in the last 110 years or something like that.
Really?
And the only time they ever turned it off was, and they were very scared to do this, was just a few years ago. They were renovating the fire station. They needed to change something out in the electrical system. And they were really worried that they were going to burn this thing out when it turned back on. It's only ever been turned off that once.
Because that's what really burns out this bulb, on and off, on and off. Now here is an LED light. I don't know if you can see it. I'll hold it up there. Yeah, you can sort of see it.
That's tiny. That's cool.
This is a tiny one. And it has two legs, and you can barely see one leg is a little longer than the other.
Yeah, I can't really.
Yeah, I'll put it.
There we go. Oh, yeah, your shirt. Perfect.
So this is a little longer. So what happens is, one of the things about LEDs, it can change alternating current into direct current. And I'm not going to show you that now, but here's what I am going to show you. If I take the longer leg is positive and the shorter leg is negative, and when I hold it up like this, nothing, because I have the longer leg on the negative and the shorter leg on the positive. It's not letting electricity through. But if I take it and I switch it around, can you see that? Yeah, this lights up because now it's going the way it wants to go. So this is one of the things that can be used to change alternating current into direct current for some of those items that require that. I'm going to show you a fun thing because we're almost out of time. This I bought recently, and this is called a torch LED. So I'm going to plug this in again.
Okay.
This is what's inside of it. You can see all of those little tiny LEDs.
Yep. Each of those squares, each of those orange squares, that's an LED.
And remember, we said LEDs don't mind turning on and off very quickly. Well, watch what happens. I don't know if you can see this.
It's kind of coming through there. It's flickering.
I wonder
if.
Oh, you want to try to shut the light off?
I don't know.
Yeah, I don't know. Sort of. You can sort of see it now.
Yeah, there we go. You can at least see the light on our faces, reflecting off of our faces as it flickers, and it looks like a candle or a tiki torch. Marty showed me this on Friday, and I instantly went and ordered a bunch of them for my patio.
So this looks like a torch. And so what's happening here is, if you bring up that picture again, it has LEDs inside. This is something that
dozens of them.
Yeah, that a regular light bulb would never be able to do. And if it did, it would burn out almost immediately.
Pretty quickly, yeah.
And by the way, if you have Christmas lights, they're LEDs.
Which is really good because LED lights don't get hot.
Right. You don't want that to happen on your Christmas tree.
No.
Anyway, this is a fun thing to have. This is what it looks like inside. This is, I don't think this was around last year. This is new technology. And it's fun and it's interesting. And I'm just...
Go ahead and leave that on.
I'm going to leave this on.
Because we have several people asking us to stick it over our head and say, I just had a bright idea. My thoughts are flickering right now, so that's okay. Yes, we are going to have, Lorna, I saw your question. We are going to have a green screen at our grand finale episode at the end of Friday. And by popular request, Marty, we have been asked to switch to the International Space Station orbiting the Earth
here we
behind
are.
us. So here we are in the International Space Station with our energy efficient, no heat LED
now look,
light bulb.
when you hold it up, you can sort of see it. You can sort of see this aura around it turning on and off. These are really cool. This is just a really fun effect. This is new technology. So I want to tell you that technology is not done. People discovering new things, whether it's uses for electricity or different ways of doing things. I mean, look at cell phones. Look at what was that. I remember 20 years ago, a cell phone was about as big as a brick.
Mm-hmm.
It was about this big and this wide, and it was really heavy.
Hello?
Yeah, it was. Yeah, I can't hear you.
Yeah.
It was like that, but heavy. And now, look at how tiny they are. You could have a watch that has more information than a room full of computers did when we first had computers going. A watch is bigger than that. And so I invite you to find something you're interested in doing. As I've told you before, my grandfather said, a man who loves his job never has to work a day in his life, or her life. So if you can find something that you enjoy doing and have somebody pay you for it, that's a formula for success.
There you go.
Because you'll be doing something you enjoy, whether it's helping people or being a doctor or nurse or being an electrician or being a computer scientist or being whatever. Find something you enjoy doing, because then life gets a lot easier and a lot more fun. Yeah. James, I know you're having you are getting sleepy.
I am not getting sleepy. This is so fascinating. Someone noticed that if I hold the light at just the right angle, they can see in the reflection of my glasses.
I can see that.
They can see the flame flickering, and that's created by dozens of LEDs turning on and off rapidly and in that pattern.
And it does look like a flame flickering.
Yes. Now, you said find something that you enjoy doing. We enjoy doing these webinars so much that we are 6 minutes over time.
Well, what can I say other than
we love our jobs.
We love what we do. And I'd like to again remind you that curiosity is a cure for boredom. If you're feeling bored, find something to be curious about, and then you have the world at your fingertips with the internet, and you could find out about it and learn more about it. And all of a sudden, that boredom is gone and it's been replaced with curiosity. So I urge you to do that.
We've been fascinated by a light bulb for the last 20 minutes. I mean,
but we're easy to please.
We're easily curious.
Yes. And so have a great day. I hope you can join us again next time. And until then, See ya and stay curious. Bye for now.